Hello friends, welcome to my YouTube channel Echo Aftab. In my today's session, we are going to understand the important properties used in matrix algebra, also called as laws such as commutative law, associative law and distributive law. Without wasting time, let us deal what these laws are. So we will start with Boolean algebra. No need to worry about what it is. Actually, Boolean algebra was invented by George Boole. So in elementary algebra, we deal with numerical operations, whereas in Boolean algebra, we deal with logical operations. It was George Boole who brought into the picture what is logic, algebra of logic, and now this algebra of logic is called as Boolean algebra. So here friends, there are three important basic laws of Boolean algebra, and they are commutative law, that is change in position for addition and multiplication, associative law, removal of brackets, distributive law, factoring of an expression. So these are the three things that I am going to deal in today's session. We are going to understand about commutative law, associative law and distributive law in relation to matrix algebra. So let us start with the first one, the commutative law. In mathematics, commutative law is applicable only for addition and multiplication operations. So here we make use of commutative law only with regard to addition and multiplication. So here we don't make use of commutative law for division and subtraction. So here commutative law states that when we add or multiply two values, then the change in order of the values does not change the result. The commutative law says we can swap numbers over and still get the same answer. So here we are having two things, commutative law of addition, that is we can say A plus B is same as B plus A, and then comes commutative law of multiplication where we say A multiplied B is same as B multiplied A. So let us start with the commutative law and matrix operations. So when we speak about commutative law, we say A plus B is equal to B plus A, that is matrix A and matrix B. When we add it up, okay, by changing the positions, will we get the same result? So if A plus B is equal to what? Then B plus A will be equal to what? Whether both will be same or no. So here friends, if I say A plus B, so as we have seen in our previous session with regard to how to add the matrices and how to multiply the matrices. So here let us start with the addition. So A plus B, so here the element 7 will be added from A matrix with the element 2 from B matrix. So 7 plus 2. So this is with regard to the first row and column. Then comes 3 plus 0. Then comes 2 plus 5. Now moving ahead to the next row, 1 plus 3. Similarly, we have come here with regard to 4 plus 4. 4 plus 4, and next in the line is 6 plus 1. And coming to the third row, 2 plus 7, 5 plus 9, and lastly 4 plus 6. So this is the new matrix that we have got it. So here what we have to do is we have to just add up the numbers. So 7 plus 2, 9, 3 plus 0, 3, 2 plus 5, 7. So we are going to get is 937, 487, 9, 14, 10. So this is the result we have got with regard to A plus B. Now we need to see for B plus A also, will we get the same thing? If you see here, just we are interchanging the place. So with regard to B plus A, it will be 2 plus 7, 2 plus 7, 0 plus 3, 5 plus 2, 3 plus 1, 4 plus 4, 1 plus 6, 7 plus 2, 9 plus 5, 6 plus 4. So what we have done over here, friends, we have just changed the position. So first we had taken A, now first we are taking B. So again, if you see, 7 plus 2 is same as 2 plus 7. So that is what we got, 9. So here also we get 9, 3, 7, 4, 8, 7, 9, 14 and 10. So we have seen that the commutative law holds good, where we say A plus B is equal to B plus C. So it holds good with regard to addition. So commutative law of addition, A plus B is equal to B plus A, does apply to matrix addition. We'll go one step ahead and see whether the same is applicable for multiplication. Now in multiplication, what it is, A matrix multiplied by B, will it be same as B matrix multiplied by A? So this thing we will see here. So we are having A matrix where 4, 9, 8, 7, 6, 2, 1, 5, 3 are the different elements, and similarly we are having matrix B. Now the first thing that we need to see is the dimensions of the matrices. This is 3 by 3 matrix, and even this is 3 by 3 matrix. So for multiplication, as I had spoken about it in my last session, we need to know whether they are conformable. Conformability is one of the important rule to test. So 3 by 3 and 3 by 3. So here this 3 and this 3. So here the columns and here the rows should be of same dimension. So it is conformable. So we are going to get, first we'll see what we are going to get with regard to A, B. So first is A multiplied by B, and this is equal to 4 multiplied by 1, 4 multiplied by 1 plus 9 multiplied by 5 plus 8 multiplied by 0. Then 4, the first row with the second column. So 4 multiplied by 2 plus 9 multiplied by 3 plus 8 multiplied by 2, and lastly 4 multiplied by 0 plus 9 multiplied by 1 plus 8 multiplied by 4. So this is the first operation. Next we need to go for the second row. 7 multiplied by 1 plus 6 multiplied by 5 plus 2 multiplied by 0. Similarly, second row, second column, 7 multiplied by 2 plus 6 multiplied by 3 plus 2 multiplied by 2, and lastly the second row with third column. 7 multiplied by 0 plus 6 multiplied by 1 plus 2 multiplied by 4. Now coming to the third row, 1 multiplied by 1, so this one multiplied by this one, 5 multiplied by 5 plus 3 multiplied by 0. So we are done with the first column of matrix B. Now 1 multiplied by 2 plus 5 multiplied by 3 plus 3 multiplied by 2. So here we are done with the second column of matrix B, and now the last part is 1 multiplied by 0 plus 5 multiplied by 1 plus 3 multiplied by 4. So when we take up these values, we will get AB is equal to 49. The next element is 51 and 41. That is 4 plus 45 plus 0 will give us 49. Similarly, 8 plus 27 plus 16 will give us 51. Similarly, 9 plus 36 will give us 41. The next one is 37, 36 and 14. 6 plus 8 will give us 14. And here 1 plus 25 plus 0, that is, it will give us 26. 2 plus 15 plus 6 will give us 23. And lastly, it will be 17. So this is what we got when we were multiplying A into B. Now, if we are multiplying B into A, will we get the same result? So B multiplied by A, will we get the same result? So in the previous solved example, A multiplied by B, what we had got? A multiplied B, we had got 49, 51, 41, 37, 36, 14, 26, 23, 17 as the elements. So I'll just repeat it over here. 49, 51, 41, 37, 36, 14, 26, 23 and 17. So this was the new matrix that we got when we multiplied A with B. Now we'll take up B into A. So matrix B multiplied by matrix A. So whether we will get the same answer for this, we need to check it out. So now what I'll be doing is, I hope till now you're perfect. So I'm going to take this row and I'm going to multiply with all the columns. So the first is 1 multiplied by 4 plus 2 multiplied by 7 plus 0 multiplied by 1. Similarly, I'm going to take the first row and multiply with the second column. 1 multiplied by 9 plus 2 multiplied by 6 plus 0 multiplied by 5. Similarly, the last is 1 multiplied by 8 plus 2 multiplied by 2 plus 0 multiplied by 3. Then coming to the next row, I'm going to get the second row with all the columns. 5 multiplied by 4 plus 3 multiplied by 7 plus 1 multiplied by 1. 5 multiplied by 9 plus 3 multiplied by 6 plus 1 multiplied by 5. So I am done with the second row, second column. Now coming to the third column, 5 into 8 plus 3 into 2 plus 2, 3 into 2 plus 1 into 3. And lastly, I am going for the third row with all the columns. So it will be 0 multiplied by 4 plus 2 multiplied by 7 plus 4 multiplied by 1. Then comes 0 multiplied by 9 plus 2 multiplied by 6 plus 4 multiplied by 5. And now the last row with the last column, 0 multiplied by 8 plus 2 multiplied by 2 plus 4 multiplied by 3. So this is what I have got. Now when I further solve it, let us see what we are going to get. So we are going to get a matrix which is 4 ones are 4, 2 sevens are 14, 14 plus 4 is 18. Similarly, 9 ones are 9, 2 into 6, 12, 0 into 5 is 0. So 12 plus 9, that is 21. And lastly, 8 ones are 8 plus 2 twos are 4. 8 plus 4, that is 12. Similarly, the next we get is 42, 68 and 49. And lastly, what we get is 18, 32 and 16. So this is what we got. So friends, you can see when we multiply A with B, we are getting this particular matrix. When we are multiplying B with A, we are getting this matrix. So we can say that A multiplication B is not equal to B multiplication A. Commutative property with respect to multiplication does not holds good. That is, AB will not be same as BA. We are going to get completely different elements in the matrix, A and B, B and A. So both these things you can say they are not equal to each other, they are different. The associative law. The associative law definition states that when any three real numbers are added or multiplied, then the grouping or association of the numbers does not affect the result. So here this is the common real numbers. So what we need to do is, here we need to take, instead of real numbers, what will happen to the matrices? If you take three different matrices and are added or multiplied, then what will happen to the grouping? So the associative law says that it does not matter how we group the numbers. So here also we are having associative law of addition, that is A plus B, that is in the bracket. So here in this thing, associative law, as I said, there are three things, A, B and C. Now how you are going to group it, that doesn't make any difference. That is what associative. So whether first I am going to add up A and B, or first I am going to add up B and C. So this is what, whether I am first adding up A, B and then adding up the C matrix, or first I am adding up B, C and then I am adding up A matrix. So what will happen to this? So in the case of associative law, both the results will be same. Similarly, associative law of multiplication, what it says, if A and B are multiplied with C and if A is multiplied with BC, whether it will be the same thing. That is what is the associative law. So here friends, the parenthesis shifts and the numbers do not change. So this particular bracket which I said, this is what is parenthesis. So the parenthesis change, the numbers do not change. So if this parenthesis we are replacing it, whether it will change the end result, that is what we need to check it out. So the second law is associative law. So the associative law of matrix addition. So here, as you know, A plus B, first we are going to add, then we are going to add the C matrix, whether it will be same as adding first B plus C and then we are going to add A matrix. So here for we have taken three matrices A, B and C, and now we will try to work out and see whether the associative law of matrix addition is applicable for matrices. So this is the case. So friends, first I will take is A plus B and then I'll add up the C. So first thing is A plus B. A plus B. And now you know it, how we are going to add it, A plus B. So 6 plus 9. Similarly, 2 plus 1. 5 plus 3. And the next is 9 plus 4. 5 plus 2. 3 plus 6. So this I am getting it as 15, 3, and 8. 6 plus 9, 2 plus 1, 5 plus 3. And next is 9 plus 4 is 13, 5 plus 2 is 7 and 3 plus 6 is 9. Now with this what we are going to do is we got A plus B. Now we are going to add up C. So A plus B, in this we will add up C. So what we will get is 15, 3, 8, 13, 7, 9. This is A plus B plus C. 7, 5, 1, 10, 3, 8. So this is going to be equal to 15 plus 7, 3 plus 5, 8 plus 1, 13 plus 10, 7 plus 3, 9 plus 8. So the end result that we are going to get is 15 plus 7 is 22, 3 plus 5 is 8, 8 plus 1 is 9, 13 plus 10 is 23, 7 plus 3 is 10 and 9 plus 8 is 17. So this is what we got. So A plus B plus C is here. A plus B plus C. Now let us see the second part. A plus B plus C. So here first what I am going to do is we will take B plus C. B plus C is equal to C. B plus C is equal to 9 plus 7, 1 plus 5, 1 plus 5, and then 3 plus 1, 3 plus 1, and then the next is 4 plus 10, 2 plus 3, 6 plus 8. So when you add up these things, what do we get? B plus C. So B plus C is equal to 9 plus 7, 16, 1 plus 5, 6, 3 plus 1, 4, 4 plus 10, 14, 2 plus 3 is 5, and 6 plus 8 is 14. So this is the result of B plus A. Now what we will do? We'll add matrix A along with this. So A plus B plus C. So what is A? We are having 6, 2, 5, 9, 5, 3. So this we are adding it up with 16, 6, 4, 14, 5, 14. So what will we get next is 6 plus 16, 6 plus 16, 2 plus 6, 5 plus 4. Similarly, 9 plus 14, 5 plus 5, and lastly 3 plus 14. So when you add up these things, what will we get? 16 plus 6, that is 22. Next is 2 plus 6, 8. 5 plus 4 is 9. 9 plus 14 is 23. 5 plus 5 is 10, and 3 plus 14 is 17. So friends, you can see here the associative property for addition is also right. So we can say this particular property holds good for matrix algebra. The associative law of matrix multiplication. Now here A into B into C will be same as A into B into C. So here again I have taken the three matrices A, B and C. Now the first thing friends here is we need to find out the conformability, whether we for multiplication we know that conformability is very important, and about this I have spoken in the last session. I'll just revise it over here. This particular matrix A, that is 7, 1, 5, it is a matrix which is having one row and 3 columns. Matrix B is the matrix which is having 3 rows and 2 columns, and matrix C is having 2 rows and 2 columns. So for conformability we need to see, can we multiply A and B? So for this, check the dimension. 1 by 3 is equal to 3 by 2. So here this thing, that is the number of columns is matching with the number of rows, so we can multiply A into B. And what is the new dimension we are going to get of AB matrix? The new dimension is going to be 1 by 2. 1 by 2. Going ahead, can we multiply the matrix AB with C? So here again we need to see the conformability. So C matrix dimension is 2 by 2. Again the columns and rows are same, so we can go on for A into B and C. Similarly A into B into C. So the conformability we have checked and we are in a position to go ahead with multiplication. So let us start with multiplication. So for this, friends, the first one is I am taking is matrix AB. A multiplied by B. So when I am doing that thing, so A multiplied B is 7 into 6, 7 multiplied by 6 plus 1 multiplied by 2 plus 5 multiplied by 3. And then again we are going to multiply the same row with the next column. It will be 7 multiplied by 5, 7 multiplied by 5 plus 1 multiplied by 4, 1 multiplied by 4 plus 5 multiplied by 8. So with this, what we are going to get is 7 into 6 into so plus 1 into 2 plus 5 into 3. So this is, we are going to get here is 59, and here this value will be 79. So this is the new matrix. Now in this, friends, we'll bring the next element, that is we'll multiply with AB C. So we are having AB with us, that is 59 and 79. With this we are multiplying C, that is 9, 3, 4, 10. Now when we do this thing, what will we get? So 59 into 9, 59 into 9 plus 79 into 3, into 3. The next one is 59 into 4, 59 into 4 plus 79 into 10, and this is going to be 768, 1026. When you multiply this thing, you will get the answer 59 multiplied by 9. For simplicity, I can tell you all 59 multiplied by 9 is 531 plus 79 multiplied by 3 is 237, and when 237 is added up with 531, what we get is 768. I hope you got it. So the first part that we wanted to know, A, B into C, we got it as 768, 1026. Now we will see what about the other way, A into BC. So first we'll take up BC. So BC is equal to 6, 5, 2, 4, 3, 8 matrix B multiplied by matrix C, that is 9, 4, 3, 10. Again the conformability is there. These are 2 rows, 2 columns, 2 rows. So it is same, it is matching. So this we can write it as 6 into 9 plus 5, change it, 6 into 9 plus 5 into 3. Next will be 6 into 4 plus 5 into 10. Similarly, the next row, 2 into 9 plus 4 into 3, 3 into 2 into 4, 2 into 4 plus 4 into 10, and lastly 3 multiplied by 9 plus 8 multiplied by 3, 3 multiplied by 4 plus 8 multiplied by 10. So this is what we get. Now when we actually multiply this thing and add it up, we are going to get 69, 74, 30, 48, 51, 92. So this is the new matrix we got it. So this is with regard to BC. Now BC is there. We will multiply A along with it. So what will we get? We are having A matrix as 7, 1, 5, and BC matrix is 69, 74, 30, 48, 51, 92. So now when we multiply these two matrices, what will we get? So by multiplying this matrix, we are going to get is 7 multiplied by 69, 7 multiplied by 69, 1 multiplied by 30 plus 1 multiplied by 30 plus 5 multiplied by 51, 5 multiplied by 51. Similarly, coming to the next column, 7 multiplied by 74, 1 multiplied by 48, and lastly 5 multiplied by 92. So when we multiply and add it up, what we are going to get is 768 and 1026. So this particular answer, so again if you see it here, what we are going to get is A multiplied by BC is equal to 768 and 1026. So we can say that this particular property also holds good with regard to matrix algebra. Now coming to the last part, the distributive law. The distributive law says that multiplying a number by a group of numbers added together is the same as doing each multiplication separately. What does it mean? It's simple. We are distributing the property. So here, if I say A multiplied by B plus C, it is same as saying A into B plus A into C. So here friends, multiply everything inside the parenthesis by what is outside it. So inside the parenthesis we are having B plus C, and what is outside? It is A. So A multiplied by B is AB plus A multiplied by C is AC. So this is what is called the distributive law. So here friends, we need to check out if two matrices, first we add it up and then we multiply it with another matrix, will it be the same with regard to the product of two matrices, then adding it up with the product of another two matrices. So this is what is distributive law. So here in distributive law friends, I have taken three matrices A, B and C, and let us see whether this particular law holds good or no. So let us start. Again, we need to first find out the conformability. So as you know, here we are having one row and three columns. Here we are having three rows and one column. Here also we are having three rows and one column. So the first thing is that we need to say is A, we are multiplying with B plus C matrix. So first thing we need to get is what is B plus C. So B plus C is 6, 5, 1, this particular matrix, plus 9, 5, 8, this particular matrix. So here we will get 6 plus 9, 5 plus 5 and 1 plus 8. So this is going to give us 15, 10, 9. Now this particular matrix, if we multiply it with A matrix, now A into B plus C, A is 4, 7, 2, this matrix multiplied by 15, 10, 9. So what we are going to get is, we are going to get 4 into 15 plus 7 into 10 plus 2 into 9 is AB plus AC. So first I will take AB. So multiplying A with B, 4, 7, 2 with 6, 5, 1. What will I get? 4 into 6 plus 7 into 5 plus 2 into 1 is 61. So we got AB. Similarly, what is the case with AC? So AC is again 4, 7, 2 with C, that is 9, 5, 8. When we go on for multiplying these two matrices, what we get is 4 into 9 plus 7 into 5 plus 2 into 8. So this is equal to 36 plus 35 plus 16 is equal to 87. Now coming to the last part, we want to check it out whether AB plus AC, what will we get? So friends, AB is 61 and AC is 87. A into B plus C, we got 148. Similarly, the second part, AB plus AC is also 148. So both these numbers are same. So I can say that the distributive law of matrix multiplication withholds with regard to the matrix algebra. So with this, friends, we have come to the end of today's class, and in my next class we'll deal with what are determinants and Cramé's rule. So till my next class, please take care of yourself and stay happy. Thank you very much for being with me, for being with Understanding Economics with Professor Aftab. Take care, be happy, see you soon. Tata, bye bye.